Hello, today we'll be doing number 86. This is course schedule. This is a little different from the other problems that we have done. The difference is that it is a graph problem, rather, well, it's a different type of graph problem where we're not given a grid anymore. It's not about going up, down, left, and right. It's about going to its neighbors. And the neighbors have requisites. So basically, it's about seeing if we can finish every single course, and every single course has a prerequisite, and see if those prerequisites can be fulfilled. If it cannot be fulfilled, then we need to return false. And if it can be fulfilled, then we can return true. So if it can be fulfilled, let's create a fulfilled prerequisites equals, currently it's set to none, times num courses. So if it is like visited or fulfilled, let's say that we have completed this course. We might be able to change this to a set later, but we'll do this for now, and we'll come back to make this a little bit better later. And so another thing is that if we're on a particular path of a node where it cycles, we want to know that there's a cycle, and that we want to know if there's a cycle, then we have to return false. So we also create an array for this. So this can also be a set, which we'll do later, but this makes it more approachable at this point. Adjacency list is where we create a list of all the prerequisites for a particular course, yes, so we do the same thing here, time nums courses, because each particular course has that item. So it's a list of lists, and this particular list goes by an index for the course, and the courses we're going to put the prerequisites in now. So for prerequisites, adjacency list, and we're going to put the prerequisites for this is the course that we'll be taking, and we're going to append the course that we need to take. So with that, we have put all the courses in. So now what we need to do is go through all the courses to see if we can complete them. So what we're going to do is traverse through all the neighbors and to see if it returns false. If it returns false, we can return false. That means it is a infinite loop, or some courses cannot be finished after processing. And so with that, we can return true afterwards. Pretty simple, right? But what we need now is the traversal. And so we're going to define it here. Traverse, and we're going to traverse the course I. So on this course, if it's on the path, that means it's already in the path. We're going to return false because it's an infinite cycle. If it's visited, if it's fulfilled, that means we've finished this course. Then that means we can return true because it is a complete course, and we can tell our neighbors this is true, and we don't need to do this particular course. If it's otherwise, it is not a fulfilled course, and it's not on the path yet. So let's put on the path and try to attempt to fulfill the course. So to fulfill the course, we need to make sure that all the neighbors in the adjacency list is complete. So if traverse of neighbor is equal to false, that means it's non-traversable, then we're going to return false, because our neighbor is not traversable, I'm not traversable, that means I'm not traversable. So if they are traversable, then we're going to take it off the path, because we're no longer accessing this particular node anymore for our DFS, and we will be always, our course will be fulfilled in the future because we have not reset fulfilledness. So let's run the code. We have a prerequisites, a problem, so I spelled it incorrectly. I wonder if there are any other issues here. Let's run it. Out of range. Right. It looks like you can't do this. Yeah. What if I did this? Doesn't work that way. Okay. So because it doesn't work this way, let's fix that to mean what I want it to mean. So I'm gonna say adjacency list is an empty array, and what we're gonna do is append the empty array to it. Okay, so it's good now, and we can submit. Very good. And that is how we solve this particular problem called course scheduling. It is a traversal type of problem where we're trying to keep track of what we have been, where we're going, and this is a very unique problem compared to every problem that we have solved, because we just don't know how many neighbors that we have. And I think it's a very good problem. I think we should see more of these types of problems to get better, more familiar with this type of problem, and so that we can do well when we see these types of problems in the interview. I think there's so much more to learn. But in this lesson, what we learned is that we need to watch out for cycles by creating a visited or fulfilled here in this, and we need to keep track of what we're going to do, and if we are in a cycle, by using a visiting on path. And we could, instead of using sets, we were able to be more, or hash sets, we were able to be more direct about our language, because we isolated by using arrays. We're telling the user, look, we only have this number of courses, and these courses can be fulfilled in this way when we add these items to it. And so that we make sure to the reader that, oh look, we know that this course is in here, rather than using a hash set and building it out that way. We also learned to write some simple code to get all the prerequisites and traverse from every single course, and traverse through the courses while keeping track of where it's at, by using one array to get fulfilled and one array to get on path. So this is very good, I think. I believe this is pretty good code. I think there is more to learn here, and I would like to do more problems, and hopefully you guys can come along with me for a ride, and we can all learn together. Thank you very much. If you enjoyed the video, please like and subscribe. If you want more, check the link in the description below, and I'll see you next time.